that is suitable for this current situation. In this case, you'll use binomial series, and that will work. Okay, so let's see how it goes. Square root x. So f of x is square root x, which means x to the, well, let me remind you, those who took my calculus 1 last semester probably have seen me doing this. Anyway, let me show you. Sometimes you can use fraction power, of course, fraction exponent, of course, right? But sometimes you can continue to use square root and make things look nicer. Okay, so but you have to learn how to think about it. This one is a power function. And what is power? 1/2. Now, when you have a power function, you take derivative, then power gets pulled to the front, and then power drop by 1. What do you mean power drop by 1? You have this square root x and power drop by 1, that means it divided by x. So I'm going to divide by x, and that's where you get 1 over square root x. Subsequently, you do the same. F double prime x. This is still a power function. What power? Negative 1/2. And so negative 1/2 get pulled to the front, and then power drop by 1. Perhaps it's not worth doing this for this particular case. So you might as well just switch to the other one. This is x 1/2. This is 1/2 times x negative 1/2. And this is 1/2 times negative 1/2 times x negative 3/2. Perhaps it's easier this way for this particular task here. So x third power, sorry, not third power, third derivative, that will be what? 1/2, negative 1/2, negative 3/2, because pull this to the front. X negative 5/2. Next one, fourth derivative. You will have 1/2, you have negative 1 over 2, negative 3 over 2, and further negative 5 over 2, times x to the negative 7 over 2, and so on. So this pattern persists. Therefore, in general, you can cook out, by now you can convince yourself that the nth order derivative, what's the pattern here? You see that, perhaps you can cook out one more. This one is f fifth derivative. That will be 1/2 sitting in front. And then you have a whole bunch of negative factor. Negative 1/2, negative 3/2, negative 5/2, and one more. Negative 7/2. And x to the negative 9/2 power. So it looks like it is like this. F nth derivative is equal to, how many powers of 2s are here? 5. This one has 4. So in general must be what? 2 to the n. So 1 over 2 to the n. Secondly, how many minus signs are there? N minus 1. N minus 1. And thirdly, forget about this 1 sitting up front. Just look at this. 1, 3, 5, 7. 4 of them. Is that right? So you're going to write 1, 3, dot, 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 2. All these are odd number. You know, how many odd number? Starting with this negative 1, right? 1, 3, 5, 7. 4 of them. 1, 3, 5. 3 of them. So in general, how many of them? 2. No, m. Oh yeah. This one would be the what I meant to say is that there are n minus 1 odd numbers. Is that right? So what is the n minus 1th odd number? Wouldn't that be twice n minus 1, right?
Minus 1.
Minus 1. Are you with me? Right, the first, 2k minus 1. The first odd number is 2 times 1 minus 1. Second one, 3 is 2 times 2 minus 1, and so on. So the kth one is 2k minus 1. So I want the first n minus 1 odd number multiplied together. The n minus 1 will be twice n minus 1 minus 1. Okay? So that's that. Multiplied by x to the what? That will be a negative number with denominator 2. Numerator would be the next odd number, is that right? Which is what?
And plus 1?
2,
2.
and this is 2n minus 2 minus 1, that's minus 3. Alright, so that would be what? Minus 1. Double check. If n were 5, then you get 9. Right? If n were 4, 2, 4 minus 7. That's right. Okay, so this is correct. Alright? Okay, now, fortunately, we can see a pattern. So this is the pattern, and then we want to evaluate at 16. So at 16, this is 4. F prime of 16, that would be 1/2 times 1 over 4. F double prime of 16, that would be 1/2 times negative 1 over 2 times 1 over 4 to the what power? Third power? Kind of annoying, you know? And so you look at the general pattern, it seems that the nth derivative of f evaluated at 16, what will we get? Well, I will have negative 1 to the n minus 1 power. I will have 2 to the n, I'm copying over from there. I would have 1 times 3 times dot 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 times the last one being what? 2n minus 3. So you have this many, you have n minus 1 odd numbers times x being 16. Right? X being 16. And so you would be 16 to the 2n minus 1 over 2 power, and then take the reciprocal. So what is that? That will be 1 over 4 to the 2n minus 1. Right? Okay? You can further clean it up. This one would be negative 1 to the n minus 1 power. This one would be, this guy would be the same as, this guy will be the same as what? 2 to the 4n minus 2. Yeah? Is that right? Is that 2 to the 4n minus 2? And that's 2 to the n. So altogether you have what? 2 to the 5n minus 2. Yeah? Okay? Not so pleasant. 3 dot 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 up to this odd number 2n minus 3.
So is it 2n minus 3 to compensate for the first term being the positive 1/2?
2n minus 3. No, I didn't even consider this positive 1/2 because you know, the odd number thing, you know, I was thinking this way. I was thinking these negative odd numbers. I take care of the negative signs first. Then I have 1, 3, 5, 7. That's from here, not this one.
Right.
Okay, that 1/2 I didn't have to deal with. So the 1, 3, 5 is this one. This 1, 3, 5, not that one.
So if you didn't go from the first term, it would be 2n minus 1.
Because you see, the way I think about it is that at degree 5, forget about this one. I will have, and forget about the signs, which I'm already taking care of. Then I have 1, 3, 5, 7. The first 4 odd numbers. Likewise, at degree 4, I have the first 3 odd numbers. And therefore, at degree n, I would have the first n minus 1. So this is the first n minus 1 odd numbers. Okay? This is the first odd number. This is the second odd number. The third odd number is 5, and so on. So what is the n minus 1th odd number? That is 2n minus 3. Okay, that 2n minus 3 comes from, in general, the k's odd number is this guy. And therefore, if you replace k by n minus 1, then you get that. And that is 2n minus 3. But the way I think about it is that this is the first n minus 1 odd numbers multiplied together. Okay? Now.
So what if it's like we ended up with a solution of n equals 1, then we have, and then we want to make it n equals 0, then we
No.
have to add like plus 1 to.
Not necessarily. It depends upon, you know. Sometimes usually you have multiple ways of writing the same thing. You know, so long as it's consistent. It's fine.
Okay, but if we want to make it to n equals 0 and we have like an alternating series, do we add the if we want to do we have to add n plus we have to add n
Negative 1 to the, you have to have negative 1 to a certain power.
Okay.
You say alternate. Yeah, alternate. So negative 1 to the nth power, or it could be negative 1 to the n minus 1 power. And it depends upon, you know, this one. What is the first? You have to examine the sign of the first one. And also the counter value n for the very first one. Whether it is 0 or 1.
Isn't there supposed to be like an x term in the class answer?
X term, here remember the x is being replaced by 16. So the x symbol is gone. And so it's somewhere here already, right? And then this 4 I write in the 2 squared and then absorb that power of 2 into that one. Okay? And if you're not too tired, you can further tweak this one. Remember I did that before? Alright, so if you were to do that, then what would happen is